But now let's go through exactly the same geometric interpretation for our lasso objective. And for our lasso objective, we have our residual sum of squares plus lambda times our L1 norm. Okay, so when we look at this first term, which is in this pink, or rather fuchsia box, we have exactly the same residual sum of squares that we talked about for ridge. So when we visualize the contours associated with residual sum of squares in our lasso objective, it's exactly the same. So residual sum of square contours for lasso are exactly the same as those for ridge. Okay, so I don't need to explain this plot again. You remember what it is from our ridge visualization we just went through. But now let's look at the term that's different, and that's looking at an L1 penalty instead of an L2 penalty. And here, if we think of looking at the absolute value of W0 plus the absolute value of W1 equal to some constant, defining one of our level sets in our contour plot, well, what does that look like? That defines a diamond. Okay, so as I'm walking along this diamond, every point along this surface here, this line that I'm drawing, has exactly the same L1 norm. So here I have my 1 norm is equal to some constant 1. Here I have the 1 norm equal to some constant 2 greater than constant 1, and so on. And again, just to be very explicit, if I look at some W0 W1 pair, I can look at any 2 points, and some W0 prime, W1 prime. These points, for any points along this surface, have the same 1 norm, W1. Okay, so if I'm just trying to minimize my L1 norm, what's the solution? Well, again, just like in ridge, the solution is to make the magnitude as small as possible, which is 0. So this is min over W of my 1 norm. Okay, so this is a really important visualization for the 1 norm, and we're going to return to it in a couple slides. But first, what I want to do is show exactly the same type of movie that we showed for our ridge objective, but now for lasso. So again, this is a movie where we're adding the 2 contour plots. So adding RSS plus lambda W1 in this case. So we're adding ellipses plus some weighting lambda of a set of diamonds. And then we're going to solve for the minimum. That's going to be x. So x is, again, our optimal W hat for a specific lambda. And we're going to look at how that solution changes as we increase the value of lambda. And again, if we set lambda equal to 0, we're going to be at our least square solution. So we're going to start at exactly the same point that we did in our ridge regression movie. But now, as we're increasing lambda, the solution is going to look very different than what it did for ridge regression. We know that the final solution is going to go towards 0, but let's look at what the path looks like. Okay, Vanna, Carlos, you're up. Play the movie. So what we see is that the solution eventually gets to the point where W0 is exactly equal to 0. So if we watch this movie again, we see that this x is moving along, shrinking, and then it hits the y-axis and it moves along that y-axis. So the first thing that happens is that W0 becomes exactly 0. Well, the coefficients shrink, and at some point it hits the point where W0 becomes exactly 0. And then our W1 term, the weighting on this second feature, H1, is going to decrease and decrease and decrease as we continue to increase our penalty term lambda. So it's going to continue to walk down this axis. So let's watch this one more time with this in mind. Our solution hits that 0 point, that sparse solution where W0 hat is equal to 0, and then it continues to shrink the coefficients to 0, and you see that our contours become more and more like the diamonds that are defined by that L1 norm as the weighting on that norm increases. Now let's go ahead and visualize what the lasso solution looks like. And this is where we're going to get our geometric intuition beyond what was just shown in the movie for why lasso solutions are sparse. So we already saw in the movie that for certain values of lambda, we're going to get coefficients exactly equal to 0. But now let's look at just one value of lambda. And here is our solution. And what you see is that because of this diamond, so let me write this as our solution. Because of this diamond shape of our L1 objective, or the penalty that we're adding, we're going to have some probability of hitting those corners of this diamond. And at those corners, we're going to get sparse solutions. So like Carlos likes to say, it's like a ninja star that's stabbing our RSS contours. So maybe that's a little brutal of a description, but maybe you'll remember it. So this is why lasso leads to sparse solutions. And another thing I want to mention is this visualization is just in 2 dimensions, but as we get to higher dimensions, instead of diamonds, they're called rhomboids, and they're very pointy objects. So in high dimensions, we're very likely to hit one of those corners of this L1 penalty for any value of lambda.